and it was working. But as you can see, the social replace, there are big latency. The latency degrades the underload, and there was no QoS adjustment between slice and surface simulation. So for the possible improvements, we can, if we do it in real life, maybe we can buy a more powerful hardware to make it more fast. And the last improvement will be to add a new slice. So this slice PLC. So this slice will make us able to control the drone, because this slice that is really fast. So to control the drone is really useful. It's the end of your education.
Okay, thank you.
Yeah, we have the video of the demo, maybe.
Oh, yeah, show the video. Yeah. That's team 3.
So, you can see we have different type of subscriber. The one are the UAV, and the other are the IoT device. We can see that the IoT device can use the GNN mesh services. So we try to run the entire architecture. So we first start the core VM, then we start the PSA edge UPF, then the IUPF series. On another VM, we run the GNB. So you can see we in this panel we can start several IoT devices, and here we can see the device register each 10 seconds. So the interface from and at the end, we can use your Python script to send a fake MQTT packets. So one packet is sent every 3 minutes, if I remember correctly, and we send fake temperature, battery voltage, and humidity. On the Mac server, we use Docker Compose to launch services, and we can see we have all of the device registered on the MQTT server. And we can check with T-Sharp if the traffic is correctly encapsulated. So now we will launch the UAV device. We can see the eggs interface. Then we use the NSBind shell with the FFmpeg to start streaming to the media intake server. We can start several streams at the same time, and we can see on the media intake server all the streams are correctly So we can use the FM Play CLI to stream, to see the stream on the MediaMagic server. So we can see the fake camera in this case. So that's the stream. And now we can use this Python CLI script, which starts the YOLO AI. So the script auto detects the stream on the server. So in this case, we see two different streams, UAV1 and UAV2, and we will try to detect some animals on the scene. So we can see detection. And I think it's, you can also try ping different address with different interface to see
Okay, that's all.
that's all.
So, any question?
Did you measure, I think you measured the rate, right? Like if you instantiated a channel of some specification, you measure to see if you can actually achieve that, right?
Can you repeat?
When you create your slides, you
Yeah.
have parameters for the slides.
Yeah.
Right. Did you measure what you could actually achieve?
I tried different parameter, but I don't see real effects. So
Like for example, if you have your slides maximum one, maybe 10 MBS, for example.
that's the only rule which is correctly enforced, I think, because when we try with Hyper3, the max throughput was capped by the profile we set in the subscriber.
So you could actually meet your limitations. Okay, so that's good. Okay, so group 3, you could try to see if the method that they use might fix your measurement, see if there is any change in the future.
What do you have a GitHub? GitHub.
Yeah.
So please share with me.
Yeah.
So I can share.
I need to make the repository public, but I can
No.
share that.
You don't-
Actually, it's private repository,
Oh, it's a private. Okay, that's fine.
but I can make public and send the link.
Usually I will share your work to students this year for reference. Because technology update every year, so we need to keep up with state of art technology. Okay, still good. But if we are, because in your examples you just have 2 UAV, right?
Yeah.
And drones. So how about we increase the number of?
I try with 4 different UAV, but I don't try more. But I think we can achieve 10,
Okay.
but not more. I think.
How about like Ukraine and Russia, or they use in the battlefield? For that kind of situations, how can you have better management for the qualities?
I don't think
And
they
also IoT signals. I mean, for example, if we cannot catch the video. For example, if the distance could be too far, then we may not be able to get the videos. So if it's possible for us to use QTT or something to get the location, position of the drone to have because network sizing is, I mean, the network should be dynamic. We may have different size. So to achieve this kind of quality of service, right? So your design, if you may not achieve some functions, you can have some backup plan to achieve something. For example, we are use drone to attack the target. We may use videos to check the location or something. Or we don't get the video. And how to do.
I don't think they use 5G
In
No.
Ukraine,
yeah, they don't use 5G. It's just like a wire, a very, very long wire.
Oh,
And
yeah.
it's like for kilometers,
yeah.
yeah. Like kilometers of a big wire, because it's better because you can't
jam
yeah.
the signal.
But how about the programs for
Or you can use satellite.
They're using fly-by-wire, literally.
Yeah.
Yeah.
Because
Fiber.
it's better and
Because you can jam the signal. There's special tools you can just aim at the
yeah.
wireless UAV and then you just jam it and it falls. You can't jam physical connections, right?
They look at it, it's
Yeah.
more difficult.
Well, it's not jamming, it's literally just cutting it off. But yeah, and,
Okay, thank you to T1 again. So let's do T2. We don't have a break. You want to go to your restroom, just go.
Sorry, I forgot to submit the video, so maybe I'll use my laptop first.
okay, Mazar, you should have done and upload the video afterwards.
Oh yeah, already uploaded.
You already uploaded it?
Yeah, but it's still not downloaded.
Where? You can download it. Well, maybe introduce yourself first.
Good afternoon, everyone. This afternoon we would like to present our 5G project titled Hybrid 5G Manufacturing Solution with Network Basic with project Julian Gobler. And on my right is John Evan and me, myself, Ahmad Rizky.
Well, yeah, first of all, a small introduction just to see why we are doing this. Modern smart factories need nowadays support of heterogeneous traffic or the same 5G infrastructure. The typical examples we are using here is one, a high bandwidth, low latency video screen for production line cameras, EMBB, and a dense small packet telemetry from many sensors, also called MMTs. The problem we are facing here is that the most lightweight 5G test beds can, well, something like registration, session procedures, but do not capture like realistic PHY mag radio effects. And very detailed radio simulators often do not implement complete control panel signaling with a real core, 5G core. And the core problem is also to evaluate slice behavior in a setting that includes, for example, realistic NR radio channel and scheduler behavior, but also real 5G functions for slice-aware session handling, and also measurable KPIs for both EMBB and MMTC services. And that's also our objective. I mean, I have here 4 different points. First of all, building a hybrid simulation with 3 5GC Urinal SIM and NS3 with 5G RENA. And then also slicing of course. And the first slice is for video traffic and second slice for IoT sensor traffic. And third point is to implement slice-aware radio resource partitioning at the NR scheduler. And the last point is to evaluate and compare the KPIs per slice under different load conditions.
Implementation. So how our group set our test bed. First we map out what is the IP, the network function, each service, URL SIM, and the data network, which is the traffic, the IP processor for video and IoT, and along with the simulation, that's the IP list for everything. Next, to simplify everything and to make the simulator portable, we use Docker container that able to basically that container serves as the bare metal server, and on top of that container we set up multiple containers for each network function, each GND, each simulator, each user equipments. Next, and this is the core network along with the slicing. As you can see, for each slice there is one SIMF, there is EMBB SIMF, there is MMTC SIMF, there is also each UPF for each slice. As you can see, they are going to different data network for different services. And as you can see, the UPF is talking with the GNB through the tunnel under ideal condition. Next, this is runtime device. This is just protocol stacks and process between GNB and 5G user. Next, so this is how the traffic simulated. So there is UIS simulator, there is MMTC process inside the simulator, there is remote host that collect the measurement result, there is GNB process that simulate the GNB behavior, along with the TPC PGV. This is for the core, slicing configuration. As you can see, the EMBB connect to single GNB, EMBB and MMTC connect to single UNB, and the core managed to connect with the different slices as I mentioned before. There is different separate SMF and UPF for each slice, because both of them have different policy and requirement. Next. And the subscriber provisioning is implemented by putting JavaScript code to insert the seed data to the core, because this is simulation. Next. This is our results.
So in our experiment, we have several scenarios. I believe it's 7. Yeah, there are 7 scenarios that we do, and this is the graphic for the average delay, and it shows that although there are several scenarios, we want to emphasize that the latency is not affected as much. So from OFDM or PM and RR, it uses a different scheduler, but although the latency is higher than usual, but as you can see from here, we have the throughput result, and the throughput result is actually exceeding our expectation. So from the graphic, the lighter color is the proposed result, and the darker color is the experiment. Is the result that we implemented. We got from the experiment. So as you can see, from different scenarios, we can modify the throughput, and we can occupy different scenarios based on the need. So we can move on to the demo itself. Demo is not interactive, but it's only
Are you running from your computer?
yeah, I ran it on our lab server, and
No, I mean,
I
because
ran.
this time you running the demo.
No, it's not running. It's a video. So
Okay.
yeah, it's just it's like all these things. So this one, first of all, we check the ongoing the running container. So just checking. So this one, we have a lot of containers, and then we check the registered NFs here. Yeah, and etc. And then we check the UE, the video session for each UE. It's already established, and also for the SMF. And then for the necessary simulation, we just want to test first on a simple scenario, and then we can move on to the wait. Let's run. Yeah, that's the test for one scenario, but this is the comparison. But maybe we can go to it's this one the one. It's a bit too fast. Yeah, this one is for the schedule comparison, and this one is the bandwidth. And yeah, if you want to run multiple, well, we have the command here for each scenarios. So this one is actually inside our source code, so we just need to run the command and it will refer to that source code for testing. So it takes here. First it goes to the baseline, and then it goes to pro the high video scenarios and then high IoT and security OFK the 40 megahertz bandwidth and then the extreme one. Just make it faster. So the first one is the baseline. So you see that we have a 2 millisecond delay with the bandwidth. The throughput is 8 bit. And then the high video and then the high IoT and so on. Yeah, it's not as interactive as other groups that we have. That they have used the week16. Is it week16 or week16 UI?
I think that's all from our group. Any question or feedback?
When you are done with each simulation, do you also check the logs?
We haven't checked the log, but
Yeah, you should always double check the logs after you run the simulation.
Yeah, but the result that I get from the output is that the data throughput is the packet is 100% empty. So
Yeah, that's the thing. So your results, I'm not saying that your results are bad. What I'm saying is that when you're running automatic simulations, it's useful to also see the logs and double check the logs to ensure that there is no unusual thing that you did not catch,
yes,
right?
yeah,
It's kind of like when you run a medical test and everything says AOP at the end, right? You still need to go through each option to see if there's not anything that's fake. That's just a suggestion.
Yeah, that's it. If we have more time, we're gonna do that.
Yeah, but for the sake of the demo, we created like our own.
That's what I did not ask you to show the logs. I just asked you if you see it.
Okay.
Right?
Yeah.
Okay, so I think it's pretty impressive. I mean, you did the full simulation stack, right? You did physical, you did the core, you did the logical part. Yeah. So, did you do a report or anything?
Oh, the report?
Yeah.
Yeah, we do have it.
So you have a report included, right?
Yeah.